Okay, so this is our second shift graph video for perfect competition. So again, we're talking about the fifth element of perfect competition coverage, which is shifts in the graph. So basically when something shocks the system, how do perfectly competitive firms react? And now I'm going to show you what happens when someone's costs fall. And this will be very different from the last video where there was a demand shock, because this is going to have much less spillovers to the larger market. We're going to assume that this is an event that's going to decrease the costs of the individual, but not change the global supply. So it's not something like fuel prices plummet, because that's going to be big enough to affect all salmon harvesters around the world and make everyone's costs go down. And that would be a very different shock than something like, let's say, Gusty invents a new harvesting technology. He gets a new net that is more efficient. Say he's a very entrepreneurial salmon harvester. He finds a new fabric that is less likely to get tangled in salmon gills. He can pick from his net faster. His marginal costs fall, and so do his average total cost, right? Each fish is cheaper for him to get. It costs him less time, lower opportunity cost, and he is a more efficient harvester because of it. But he's the only one with this new net, we're going to assume, right? That's not going to be large enough to affect the entire market. So, once more, what we want to do is start from our long run equilibrium. We have the global salmon market here on the left. Supply slopes up, demand slopes down. We're talking in price and quantity space. The global supply of salmon coming from everything from Norwegian farmed fish to all the other wild harvesters in Alaska, and the global demand from salmon coming from consumers all the way from England to China, set the global quantity of salmon consumed and produced, and the global price. Okay. Our individual is over here. Gusty, the scrappy salmon fisherman from Koliganek, he is just a tiny drop in this bucket, so he has to accept that global price as given. He is a price taker. It becomes his demand curve. His marginal cost tells him how much to produce, where marginal cost is equal to marginal revenue. That tells us the profit maximizing level of output for an individual, QI star. And his average total cost, if we're starting from long run equilibrium, can only be in one place, where it sits its little butt down on the demand curve, right? Because here, profit will be zero, price is equal to average total cost, and marginal cost is hitting average total cost at its minimum, which are two things that have to be true in the long run of perfect competition, okay? So let's think about the effect of this event, Gusty inventing the new net. I'm going to erase my description of the event so that I can keep track of the consequences down here. First thing that's going to happen is that an individual's marginal cost and average total cost fall. When I say costs fall, you can simply shift those curves vertically down. Because remember, I forgot to label it, but we are drawing in dollars per unit space. We're thinking at each quantity that Gusty produces, what are his dollars per unit? And if he invents a new net, his marginal cost at every quantity is going to be lower. That means it is vertically shifted down. So just draw like a parallel shift in marginal cost. The new marginal cost curve is just vertically shifted down from where it started. Also going to affect his average total cost. There will never be an event that changes the marginal cost and leaves the average total cost unchanged, right? Because remember that marginal cost per unit is what shapes average cost per unit. So average cost per unit is going to fall. You could just draw another parallel shift, remembering that they have to hit each other at average total cost minimum. So that's the only thing that matters. It doesn't have anything to do with this black quantity, even though it kind of seems like it does. This is irrelevant now. Because after Gusty's costs are lower, he's going to want to fish more. We're always looking for that golden rule point where marginal cost is equal to marginal revenue. That will tell us the optimal quantity for the individual. Sorry, I just realized this marker is way finer. So I'm going to rewrite this. So looking for where marginal cost, the new green marginal cost, is equal to the old marginal revenue, because Gusty inventing the new net did not affect anything over here, so Gusty's price is still where it started. Marginal cost equal to marginal revenue happens there, where the marginal cost curve hits the marginal revenue horizontal line. I'm just being a little bit particular about my labels. Gusty, as a result of his cost going down, is going to fish more. That makes sense, right? You invent a new, more effective net. Your cost per fish is lower. They're going to go out and get more fish. It's kind of like an improvement in technology. We assume in chapter 3 that that will shift supply to the right. And when firms' technology gets better, at every price they'll be willing to supply more. Right? Gusty's willing to fish for longer when it doesn't take him as much time to get every single fish. Okay? The other thing we need to show is what happens to Gusty's profit. You can imagine, because you know his cost went up, that his profit is going to rise. But you also need to be able to show that on the graph, right? Make the graph your friend, let the graph tell you the answer. The way we get profit is we look at this new quantity where Gusty's producing. What is the vertical distance between price up here and average total cost down here? And so this is Gusty's price right there where it started. Its average total cost, it's tricky to see, comes from the point where quantity hits the average total cost curve. So because his average total cost is lower after the shift, his profit is that rectangle there. It's greater than 0, because remember, profit is P minus ATC, and now P is up above ATC. That's the vertical part of the rectangle, and quantity is the length, right? So quantity is the horizontal measure, and he's now producing more fish. Okay. So after Gusty invents a new net, his costs are lower, he produces more fish, and he makes more profit. What do you think is going to happen in the long run? Normally, the long run is always a story about entry or exit. Remember in perfect competition, other firms are like flies or other animals. They can smell profit a mile away, and they come buzzing over as soon as they sense it. So Gusty's making a profit. But he is one individual making a profit. Is that really going to be enough to induce people to enter and take that profit away? I don't think so. Unless they can really imitate his technology, they're not going to have an incentive to enter. They're going to see one guy who's no longer the average, right? We said this individual panel over here reflects the average individual. If one person is making a new net and having a profit, Gusty is no longer the average, right? So I think there's one of two things is going to happen in the long run. The first is maybe Gusty guards his new technology. He's the only one making a profit. And Gusty makes profit forever, right? Long live Gusty. We hope so. We hope that he can retain the patent to his new net. He's the only one that uses it, and he makes profit forever. Maybe we hope that happens. But what if other people can imitate the technology? If other people start imitating him, that will really change things. That means everyone's costs go down. And when everyone's costs go down, supply goes up, right? One of the determinants of supply since chapter 3 has been the cost of inputs, the cost of production. If everyone learns the new technology, that's equivalent to supply increasing. It's not entry, you could kind of think of it as entry, but it's more like technology imitation, innovation spreading out to other firms, which we tend to think of as being a good thing, right? It should increase everyone's profit and it should lower prices for consumers. But in perfect competition, it's not necessarily good for the average firm. If people start imitating, there'll be more salmon bought and sold in the market. The technology spillover for consumers will be lower prices globally. The price for salmon will fall. But for Gusty, his price is going to fall, right? Marginal revenue is going to fall, demand is going to fall. It's like other people came in and copied what he was doing, so now the price is lower for everyone because they're all doing it. Everyone's able to produce fish more efficiently, then that's going to spill over to lower prices for everyone. And it is a little complicated to see here, but we end up back at the quantity where we started. Gusty's no longer getting the sole benefit from his technology, so his price is lower. His costs are still on the new green line, but he's going to produce less fish than he was when he was the only one using this technology, and his profit will be zero again. So if everyone imitates him, supply will rise, price will fall, individual quantity will fall back down, and profit will be zero again. I don't think that's inevitable. I think that depends on how easily people share ideas in this fishery. Whether there are patents that make sure you alone experience the returns to innovation. Whether this net works in other parts of the world. Maybe it's something that only works for a certain type of salmon in a certain river, and then the people in that river could make increased profit forever. And it really depends on more the technological innovation side and how that gets handled. But I think it is an interesting case to think about. So a great way to prepare for the exam, to prepare for potential questions, would be to think about what happens when the opposite occurs. What happens if an individual's costs go up and there's necessarily no spillovers to the larger market? It's not an event that's big enough to affect global supply. Let's say Gusty breaks his leg. What happens to Gusty in the short run? What happens to him in the long run if he breaks his leg? Okay, so that's the end of the cost shifting video. I hope you found this helpful, and I look forward to talking about other shifts in groups together on Monday.